Yes, sir.
Right. Good morning, students. I am Narsimha, Faculty of Physics, Borabanda Girls Campus. So today, we will start with the chapter number 8, that is magnetism and matter. So here, we'll see the definition part. We'll start with the definition part, that is what is magnet and all. It is a piece of matter when it is suspended, when it is suspended freely, when it is suspended freely, and it comes to its original position, particularly in direction north and south, and it attracts the materials like iron, cobalt, nickel, etc. towards it. It is called magnet. So I am repeating. So it is a material when it is suspended freely. It itself comes to its regular position, that is north and south, and also it attracts the materials like iron, cobalt, nickel, etc. So that material is called magnet. So this magnet is usually available in two types, that is natural magnets and artificial magnets. Here, natural magnets means they usually found in nature and they are weak magnets. Example, magnetite. Actually, it's the old material of the magnet, that is FeTO4. And another type of magnet, it is manufactured. That is that we can prepare with iron, steel, cobalt, nickel, etc. and they are very strong magnets. So, magnet is a material, it has a property of attraction and it shows the direction, that is north and south. And these are of two types, natural magnets and artificial magnets. So, natural magnets are usually found in nature, and artificial magnets that we will prepare with the certain materials like steel, iron, cobalt, etc. Okay. Now these are different shapes of magnets. Right? You can see different shapes here. That is U-shaped magnet, circular magnet, bar magnet, horseshoe magnet, cylindrical magnet, and ring magnet. And these are available. Right? So these are mostly we can see them in various situations, daily applications like ATM machines, credit cards, audio headsets, and computers, etc. And here we are among these we are going to specify for the bar magnet as per our syllabus. We will discuss the properties of bar magnet. So here is the bar magnet. We discussed that it has two properties, especially that is attractive property and directive property. So the material that attracts the piece of iron, cobalt, nickel, these are the regular examples. But this property is called attractive property. So I am repeating, the bar magnet has a specific property that it attracts the materials like iron, cobalt, steel, etc. And directive property that when the magnet is freely suspended, means whenever the magnet is freely suspended and it is rotated in any direction and it comes to its original, it's a regular position, that is north-south directions. I'm repeating, when the body is freely suspended, originally it aligns towards the north and south directions. Even though you rotate it in other directions, other than north-south directions, and leave it and comes to its regular north-south direction. So it has that property, that is directive property. So bar magnet, the attractive property and directive property, attracts the materials like iron, cobalt, steel, nickel, etc. And the directive property always shows north and south directions. So these are the properties of bar magnet. And here comes the specifications of a magnet, means the terms should be known. That is, first point is, in the magnet, the two poles will be there, two poles, that is north pole and south pole will be there. These are the places, poles means what? These are the places where more attractive power is present. In the magnet, the attraction will not be there at all the places. The maximum attractive power will be present at a particular point. So those points are called magnets. The places in the magnet where the attractive power is maximum is called poles of the magnet. Have you observed in the diagram, north pole and south pole, and these dots, black dots, are not exactly at the edges of the magnet. They are just away from the edge, just inside the magnet. So with this, we can say that the magnetic power, which attractive power, is more concentrated at those black dots as shown in the figure. So the black dots represents that more attractive power, means the whole magnet doesn't have the same attractive power. Only at the poles more attractive power is present. So that place actually we name that as a pole, that is north pole and south pole. So I'm repeating this statement that the places in the magnet, where the attractive power is maximum is called poles. Okay. Now next point. In this magnet, the line joining the 2 points. So here south pole and is the north pole. So the line, which is dotted line, is appearing here, the dotted line. So this line passing through these poles is called magnetic axis. I'm repeating, the line joining the 2 poles of the magnet is called magnetic axis. So remember this point. On this we need to do more discussions, that is on magnetic axis. And now the shortest distance between the 2 poles of the magnet along the axis is called magnetic length. Don't confuse here. Magnetic length is different, geometrical length is different. Here is given shortest distance between the 2 poles. That is, north pole and south pole is there, and the distance between them is called magnetic length. So as you know, north pole and south poles are not exactly at the edges of the magnet. Those are just inside the magnet. So that distance is called magnetic length. But originally from one edge to the another edge, so that length is called geometrical length. I'm repeating, geometrical length is length of the magnet, and the distance between the 2 poles is magnetic length. So magnetic length is the distance between 2 poles, and length of the magnet is total size of the magnet. This tends to be understood. So here some laws to be discussed. Laws of magnetic poles. Okay, laws of magnetic poles that to be discussed here. See, unlike poles attracts and like poles repel each other. Unlike poles attract and like poles repel. See here, the right side top corner, you can see the picture, opposite poles. See, south and north poles are attracting and similar poles are repulsive. Okay, so north repulsive, south are repulsed, and here unlike poles are attract. This is very important property of the magnet. And the two poles of magnet, the next one, the two poles of the magnet, north pole and south pole, have equal and opposite in nature, that always having the same quantities, same nature, whatever that may be a strength, that may be a ability of attracting, whatever, but all are in opposite in nature. Okay, that is like north pole and south pole in positive and negative light. Okay, the two poles of the magnet, that is north pole and south pole, have equal and opposite in nature. Now moving to the third point is, magnetic poles always exist in pairs, even the magnet is broken into two pieces. So here that you should remember, that is left side top corner, you can see there is a magnet and it is broken into two pieces. And again, each piece behaves as a magnet. Again, each piece behaves as a magnet. Again, it forms north pole and south pole. And similarly, see here it is made a number of cuts and further, and each piece is again further cut into number of pieces, and each piece is again acts as an individual magnet. So with this, we can conclude that in the magnet there is no existence of monopole, means there is no question of single poles. So always the magnet exists with the two poles, that is dipoles. So I am repeating, magnet always exists with the dipoles, two poles. Okay, so after breaking this piece of iron, it behaves, each piece again behaves as an individual magnet. So each magnet again exhibits north pole and south pole. So with this we can conclude that there is no existence of monopoles, means single poles cannot be existed. This is very important point. Single pole cannot be existed. Now we will move on to the next very important definitions related to this is pole strength. So pole strength is very important definition here, important concept here to be understood. Pole strength. See, we know what is pole. So pole is what? Where the maximum attractive power is present. Pole is what means maximum attractive power is present. Now, pole strength usually indicates with a small m. It is the ability of the pole. It is the ability of the pole to attract or repel the another pole of the magnet or magnetic substance. I'm repeating. Pole strength is, it is the ability of the pole. So whatever the magnet you take, to that two poles will be there. Now keep another magnet towards that, then the first magnet has an capability or ability to either attract or repel another pole of the magnet. So how strongly or quickly or rapidly it attracts, how quickly, how strongly, so that depends on the strength of that given magnet. So here pole strength is what? It is the ability of the pole to either attract or repel the another pole of the magnet which is kept near to that substance. Okay, so this is pole strength of the given magnet. So usually it is a scalar quantity and SI unit for this is ampere meter. Okay, so pole strength is a scalar quantity, it has only the magnitude and it measures with the ampere, and ampere meter is the SI unit for that. And this bar magnet has two poles separated by the distance is called magnetic dipole. As we discussed here, always the magnet exists with the two poles, so that's why we name that as a dipole, magnetic dipole. I'm repeating, magnet has always two poles which are always separated with some distance. It is called magnetic dipole. So simply the magnet is a magnetic dipole. Now the product of pole strength. The pole strength just now we discussed, that is capacity of either attracting or repel the another magnet. So here comes magnetic moment. It is the product of pole strength and the magnetic length. What is magnetic length? That we have seen in the last diagram. That magnetic length. So from the center, either sides, from the center of the magnet to the either sides, that is the distances of the poles from the center of the magnet. That is indicates with 2L. So each side, so from the center, right side, for example, north side, it is the distance is L, and from the center, left side, for example, south one, it is L. So total distance between the two poles is 2L. So the product of pole strength and the magnetic length 2L gives the magnetic moment of the magnet. So this is very important definition, that is what is magnetic moment. It is repeatedly comes number of times in the coming discussions. That it is the product of pole strength and the magnetic length is called magnetic moment, indicates with a capital M. So here is the formula, capital M is equal to M into 2L. So it is a vector quantity, it has both directions and magnitude, and it is measured with the unit, it is ampere meter square. Ampere meter square. So these are some of the main discussions, and we will move on to the next one. See here, most point is magnetic field. It is very important. Magnetic field. What is magnetic field? See here, you can see in the diagram that there is a magnet, and around that you can see lines are there. So moving. So if you see the arrow marks in the diagram, that coming out from the north direction, north side, that is north pole. So here the lines indicates the magnetic field. The lines indicates the magnetic field. So here, as the definition, it is the space or the region around the magnet is called magnetic field. So here this magnetic field that we can't see. Magnetic field that we can't see, that imagine that represented with some lines, here. Okay, so it indicates the lines of force. So here is the magnet. So here the lines of force are coming out. From the north pole. That around this magnet, the field that we are indicating with, the lines of force. Right? So the field that we can't see, physically we can't see that, and so that's why it is represented with the lines of force. Okay, so it is the space or a region around the magnet is called magnetic field, and it indicates with the lines of force, and these lines of force are imaginary and they do not exist in reality. Okay, so directly we can't see that the field. Okay, so that field indicates with the lines of force here. And see the nature of lines of force here. And always these lines of force comes out from the north pole. These lines of force comes out from the north pole of the magnet and travels in the medium, travels in the outside the magnet, travels from the north pole travels from the North Pole and comes out from the North Pole, travels in the air medium and re-enters into the South Pole. See the arrow marks in the diagram. Okay, so this is the nature of the lines of force, that is magnetic field. I'm repeating, magnetic field means that this is the magnet, around that there is a field that is indicating the lines of force, and always these lines of force comes out from the North Pole and re-enters into the South Pole. This is the nature of the lines of force. So here inside the magnet, if you observe this, inside the magnet, the lines of force are moving from South Pole to North Pole. This point is to be understood. So outside the medium, the lines of force are moving from North Pole to South Pole, and inside the magnet they are moving from South to North. Very, very important. See, if you say, means the question will be asked like this: the magnetic lines of force will move from which direction to which direction? So both are correct. That is moving from south to north and north to south. But you should mention inside the magnet or outside the magnet. That you should mention. I am repeating. If it is inside the magnet, the lines of force are moving from south to north, and outside the magnet they are moving from north to south. So this point is to be understood. See, your answer will be correct. That is, lines of force are moving from south to north and north to south. But you should mention that inside or outside the magnet. Okay, so these are the points to be remembered. And we'll move on to the next is characteristics of lines of force. So if you understand these motion of the lines of force, in which direction they are moving, then so much information is to be collected on this concept, that is lines of force. So here, as the magnetic lines of force moves from the North Pole to the South Pole outside the magnet, and from South Pole to North Pole inside the magnet, they have neither origin nor the end. So this is very important. That why you see one of the questions, the very short answer questions are there in your textbook, that why they makes a circular closed loops. This is the reason that why the lines of force are closed loops, like some question is there. So for that, this is the answer, that there is no starting point and there is no ending point. So they have neither origin nor end. So it is a continuous motion. Continuous motion. So it is comes out from the North Pole and re-enters into the South Pole, and inside the magnet we will move from South Pole to the North Pole. And on these lines of force, tangent at any point to the field lines gives the direction of the field at that point. And repeating, if you draw a tangent at any point to the field line, so take any field line which is moving from the north to south, try to draw a tangent on that line, gives the direction of field at that point. So I am repeating, take any line of force which is moving from North Pole to South Pole, and try to draw any tangent to that. Then that direction, that tangential direction, gives the direction of field, direction of magnetic field. And the two magnetic field lines never intersect each other, and if the two lines of force are intersected at that point, then the field should have two directions, which is not possible. Always, this point is to be more discussed. Very important. Here, the field doesn't have two lines of force, and these lines of force never cut, or merge, or overlap. These lines of force never cut or merge, because they are individual. So those lines of force indicates only the directions. So there is no possibility of intersecting each other. If they are if they are intersected, then the magnetic lines of force has two different directions. For example, we have a device to measure the magnetic field, that is a magnetic compass. So magnetic compass is the device that shows the direction. So if you are keeping a magnetic compass at a point where the two lines of force intersecting, then which direction this magnetic compass will show? It is not possible to show the two different magnetic directions. So with that we can say that there is no possibility of different directions of the magnetic field. Means there is no question of intersecting of two lines of force. So with this, we'll stop for today, and we'll continue the next class.